Am I audible? My slides are visible. Can you please confirm through the chat? Okay, thank you. So, should I start? Okay, I'll start. Okay, I'm starting now. So, hi everyone. I am Anuj Kumar, and I will be working as a PMRF TA for this course, which is Coordination Chemistry, and in short, it is the chemistry of transition elements. Okay, so the course is instructed by Professor Devasis Ray sir, and in by the Department of Chemistry, IIT KGP. Okay, so. So these are the this is basically the course plan, the week wise course plan. Okay, so for this course, actually what will be the uh, flow pattern of this basically the assignment session or interacting session. I will show you some question. Okay, so I will be waiting first for 1 to 2 minutes for getting your answers for that questions, and after that I will tell you the answer and explain it. Okay, so and now onwards, one by one, I'll show you the questions, and you can try to answer. Most probable answer you will tell me, and I will explain you after that. Okay. So so the first question is, you have to basic question: what is the bond angle of a water molecule? These are four options here. First is 104.5 degree, 109.8 degree, 180, and 60. Okay, so I will be waiting for 2 minutes for your answers. Okay, and after that I'll explain. Okay, that's fine. You can just type in the chat box. Okay, I will be okay. Yeah, I will be waiting for everybody's answer in the chat box. That will be, I think, fine for me and everyone as well. And if one question one is done, and you can attempt the second one also, because both questions are in the same slide. Okay, let me show. Okay, 10.5 degree. And the second one is what type of bond formation occurs in the water molecule and the metal ion? It is covalent, coordinated, ionic, and none of these. For second, getting the answer covalent. Okay, so let me explain these. So focusing on the first one. So water has a four regions of electron density around the central oxygen atom. Okay. So two bond pairs are there and two lone pair are there, right? So basically these are sp3 hybridized. Oxygen is sp3 hybridized and arranged in a tetrahedral shape. But if I talk about the molecular shape, that is basically a band shape with an deviated angle of 104.5 degree. You have already read that in your 12th standard or something like that. Okay, so the first option will be the right one. And the second, water is a very weak polar solvent. Okay, not, we cannot say weak, is a polar solvent, so it produced a dipole, right? Because of this electronegativity difference, it produces dipole, right? So what it will be, the it basically, the oxygen pushes or pulls the electron density of hydrogen towards itself because of the electronegativity difference. So there can be a dipole generation like this. Okay, so the positive metal ion will be attracted to a slightly negative oxygen atoms in the water molecule and form a coordination bond. Okay, so in the earlier lectures, you have read already, if this is a metal ion and if it is in the solution of, let's say, aqueous solution. Okay, so these water molecules generate a coordination sphere, right? So these can make a coordinate bond with the metal, right? Those lone pairs can easily donate to this metal center. Okay, if I consider the very easy case, let's say in ammonia molecule, everybody knows that is ammonium positive. Okay, and as for plus, if I draw the structure, okay, so this bond is basically the coordinator bond. Okay, so similarly here the formation of coordination bond take place, right? If it is clear, please type it is okay, so that I can move forward. Type of bonding will be further explained when you will read the valence bond theory and field theory. Okay, so here in basically it is a introductory assignment about the coordination chemistry. Okay, so I think it is clear, right? So moving forward to the next one. Okay, so this question is related to, okay, this one. Okay, so the next one, it is basically related to the Werner's theory. Okay, so how many moles of silver chloride are precipitated when an excess amount of silver nitrate is treated with 1 mole of this complex, that is cobalt chloride with 6 hexacoordinated of ammonia molecule. Basically, silver nitrate tells about how many chlorides ion are there outside the coordination sphere, because those the chloride ions which are present in the outer coordination sphere, those can only precipitate it with silver nitrate, right? So that is basically the Werner experiment. Okay, I'm getting the answers now. A, that is 3 moles. Okay. Who has given the answer for A? The first one, they can he or she can move forward to the second one of this slide. Okay, so let me explain. So, first, I will read the question second also. Which condition is required for the hydrolysis of this complex, hexa aqua complex with iron? Okay, so neutral pH is required, less than 7 pH or acidic pH, you can say. Acidic medium is required, basic medium is required, or none of these. Okay, so the explanation for the first one: when an excess amount of silver nitrate is added to 1 mole of this, okay, then 3 moles of silver chloride will be precipitated, because these 3 chloride ions are outside the coordination sphere. Basically, this was the practical experiment that was done by the Werner. Okay, so in 1 mole of this cobalt chloride 6NH3, there are 3 chloride ions outer the coordination sphere. So these 3 moles of chloride ions are precipitated by the reaction of an excess amount of silver nitrate. Okay, so the 3 moles will be the right answer for this one. Second one is a very interesting question. In at neutral pH, this aqua complex is present as this foam, right? And here, water molecules are connected with the metal ion center through the coordinated bond. Okay, so let me just draw it. Okay, so I am taking the two molecules for understanding. Okay, so what will be happen? So at acid, in acidic medium, okay, it basically depend on the pK value. Okay, pK, you know, the related term related to the dissociation. Okay, so this proton may lose in the acidic medium, right? So when this proton is removed from the water, then hydrolysis occurs. Okay, so this proton is removed. So what entities remain here? That is basically the hydroxide. Okay, so one water molecule is basically converted into the OH, and five remain intact. Okay, so this complex is formed in the acidic medium only. So the less than 7 pH is required for the hydrolysis. Okay. So the next one, please try to attempt. Which complex is formed when concentrated HCl is added in this complex? So basically, HCl, hydrochloric acid, is the source of yeah, yeah. Okay, so okay, so these are the next two problems. Please try to attempt. Here, HCl is the source of chloride only. You have to keep it in mind. The second one, which is the correct statement regarding transition metals. So this is basically the properties of transition metals are listed here. First is they form colored complexes. That is also right. They exhibit variable oxidation states. That is also right. Electrons from both the inner D subcell and outer S subcell can be involved in the compound formation, because basically it is talking about the hybridization. You can see hybridization can take place in outer form also, and it can also form D2sp3. Basically the structure of both the hybridization is tetrahedral, right? So these all statements are correct. Okay, and if I talk about the first one, okay, so when concentrated HCl is added to this complex, hexa aqua nickel complex, a tetrahedral anionic complex of tetra chloronickelate is formed. Okay, so here HCl is the source of chloride ion species, and the central atom, that is this one, is tetrahedrally surrounded by four chlorides and form this one. Okay, and the second one I already explained to you. So this the next question is related to the geometry of this. Okay, okay, okay. Are you taking the screenshot, right? Oh, okay. Basically, this content will be shared to you via link. Okay, you will get the copy of complete PPT. Okay, at the online class portal, you will see that there is a session, interaction, something like that, and you can find the link for the PPT and the video as well under that link. Okay, so I think there is no need to take snaps and all. Mhm. Rather, whether it will be up to you, you can take. Okay, so these two questions, please try to respond to these. Okay, let me show the solutions. So this is basically the structure of this ion. Okay, so I was talking about this structure, that is CrO4 anion. Okay, so that is basically a tetrahedral structure. Okay, only you have to draw the structure and you can tell the geometry. Okay, and the second one, the number of donor atoms present in the monodentate. So basically, as its name indicate, so there is one atom present in the monodentate ligand. Same is explained here. Okay, so monodentate ligands are loose bases that donate a single pair of electrons to a metal atom. So monodentate can be either ions or they can neutral molecules. Okay, so it can be this water molecule or it can be ion form. Okay, so these were are the monodentate ligands. So the next two question is which one is not an example of monodentate ligand, and the second one is which metal ion is responsible for the blood red coloration with the addition of this thiocyanate ion. Okay, so I will wait for 2 minutes to get your answers, and after that I'll explain. So as I have explained earlier, so the monodentate ligand is what? It should basically contain one donor atom that can basically donate the electrons to the metal atom. Okay, so in NH3 it is nitrogen, in water it is oxygen, and thiocyanoto-nitrogen, that is basically NCS. So this one is the donor atom, right? But in oxalate, let me draw it. Okay, so in oxalate there is more than one donor atoms, right? So this is not an example of monodentate ligand. Okay, so the oxalato will be the right answer for this. Okay, and the second one, which metal ion is responsible for the blood red coloration? Okay, so in the blood there is iron present in plus 3 oxidation state. Okay, so this thiocyanate solution is added. Okay, so this blood red colored solution is obtained. Basically, the red color is due to the this ligand to metal charge transfer reactions. Okay, so this is a complex that is formed by iron plus 3 oxidation state with the thiocyanate anion. Okay, again the very basic question: how many non-bonding orbital is available in ammonia molecule? You can easily answer it. Okay, so try to answer. I have already drawn the structure of ammonia. So one non-bonding orbital is there. Okay, so these are the next two problems. Among the following, which ligand can act as ambidentate ligand? Okay, and the next one is how many chromium oxygen bond present in the dichromate anion? Okay, so basically, what are ambidentate ligands? Okay, so if I talking about thiocyanate S and thiocyanate N. Okay, so basically this thiocyanate anion can exist in two forms, two tautomeric forms, right? It can exist as NCS, it can exist as SCN. Okay, so these type of ligand can are called as ambidentate ligand. So because the nitrogen can also donate its lone pair to the central metal atom, or sulfur also can donate. Okay, so basically you have to choose which ligand can act as the ambidentate ligand. First try to draw the structures of all the given ligands, and after that you will get the information automatically. Okay, the first option, there only phosphorus. There are no two elements. Okay, so I will be waiting for 2 minutes. Okay, so let me draw the structures. So if I draw the structure for this one, it will be something like that. This C6H5. Okay, and if I draw the structure for this one, that is basically C6H5 and C6H5. Okay. Okay. So in this condition, you can see the sulfur and oxygen both can contain lone pair. But in this situation, only oxygen contain lone pair. So what is the conditions for ambidentate ligand that at least two atoms can contain their should contain their lone pairs. Okay. So this condition is satisfying for this one. So this will work as the ambidentate ligand, right? If it is not understood, please type in the chat box. I'll explain. Okay. So the next one is how many you have to just count the chromium oxygen bond. Nothing special here. So if I draw the structure for dichromate anion, okay, so it will look like this, right? So how many bonds are there? One, two, three, 4, 5, 6, 7, and 8. Is it okay? I am just waiting for your responses. Okay, let me see. Okay, no issue. The next one is in the complex formation, the central metal atom or ion act as a Lewis base, Lewis acid, Bronsted acid or Bronsted base. And the next one is related to the chelation. Okay, so as you know, Lewis acid and Lewis base. Lewis base is that which can easily donate the lone pair. Okay, and Lewis acid is the acid which can accept those lone pairs. Okay, so Bronsted acid which can donate its proton, and similarly Bronsted base is which can accept that proton. Okay, so the central metal atom, let's say if it is metal positive, it is already uh, electron deficient, right? So it will work as a Lewis acid, because if any ligands is there, oxygen containing lone pair, it donate its lone pair to the central metal atom. So the ligand will work as a Lewis base, okay, and this metal will work as Lewis acid because it is electron deficient already. Okay, the next one, which of the following can act as a chelating ligand? This SH negative water molecule, thiocyanate ion, or this is uh, basically the glycinate anion. This is glycine, and this anion is given here. Okay, so if I draw the structure CS2 COO negative, yeah, it is glycinate anion. Okay, so it can easily form a chelate. Basically, that phenomena is called chelation. What happens? This is a metal, central metal ion, and basically this nitrogen site and this oxygen site can easily simultaneously make the bonds. Okay, so this will be the right answer for this one. The next one is you have to calculate the coordination number and oxidation state of cobalt in this complex. Okay, and same here you have to calculate the oxidation state in this complex. Okay, so I will be waiting for 2 minutes for your answers, and after that I'll explain. Okay, so first I will start with the calculation of oxidation state. Okay, let us consider the oxidation state of cobalt is X. Okay, so these two are the neutral molecules, right? And this chloride is basically the chloride negative. So if I calculate 2 into minus 1 and plus 1 is the total oxidation state of this complex. Okay, so x minus 2 equal to 1, so x equal to plus 3, right? And similarly here x minus 2 equal to 1, x equal to plus 3. Okay, and what about the coordination number? Basically you can see the number of ligands is here 6, 2 ammonia molecule, 2 water molecule, and 2 chloride ions. So the coordination number is 6 and oxidation number is plus 3. And similarly here the next one is ethylene diamine tetraacetate ion, basically EDTA. Okay, is a ligand with denticity. You have to tell the denticity of this ligand. Let me just, this is the typical structure for this ligand. Sorry, this nitrogen is here. Okay, just you have to calculate how many donor atoms are there Okay, by what I was telling, you have to just calculate how many donor atoms are there. That will be the denticity of your ligand. Okay, so one nitrogen atom is here, one is here, and four tetraacetate is there. So total denticity will be six, right? Okay, so the total denticity will be 6 for this EDTA ion, anion. Okay, the next one is among the following, the compound that is both paramagnetic is and colored. Okay, so what you have to do, you have to just draw the electronic arrangement of each metal here. Okay, if I talk about here, this potassium is 2 positive, right? So the anion will be Cr2O7 minus 2, right? And what will be the oxidation state of chromium here? That will be 2x minus 14 minus 2. That is plus 6. Okay. So if I talk about the electronic configuration of chromium, that is basically 3d6. And plus 6 means these 6 electrons are already donated. So there is no electron in d orbital, right? So for the condition of paramagnetism, there should be at least one unpaired electron. Okay, so there are no electrons, so this option will be incorrect. Okay, if I talk about this one, that is basically ammonium 2. So that will be plus 2 here, and it will be like this LiCl6 minus 2. Okay, so what will be the oxidation state of lithium here? X minus 6 minus 2, that is x equal to plus 4. And lithium has atomic number of 3. How it can lose 4 electrons, right? So that is also incorrect option. And if I talk about the third one, okay, so what is the oxidation state of vanadium here? What about oxygen? That is minus 2, and sulfate is overall as minus 2. So vanadium will be plus 4. Okay, so vanadium will be plus 4 oxidation state. So what is the electronic configuration of vanadium? That is 3d5. Okay, and after losing 4 electrons, it will be 3d1. So if I fill this electron, it will be like this. Okay, so the paramagnetism rises here, and this is the free electron that can even transit to any of the orbital. So that is the primary cause of the color. Okay, so this will be the right answer for this. And if I talk about the fourth one, let me just erase it. Okay, so this potassium is 3k. Okay, so what will be the charge on the complex? It is CuCN4 minus 3. And what will be the oxidation state? That will be plus 1. This copper will exist as plus 1. And what is the electronic configuration of copper plus 1? If I talk about the neutral copper, that is will be 3d 10 4s1. So plus 1, in case of plus 1, this electron will be donated, and it will show the electronic configuration of 3d10. Basically, that is the fully filled orbital. Okay, so that also will not be paramagnetic, that will be dimagnetic. Okay, so I think both the questions is clear to you. The next one is, you have to calculate the oxidation state of metal ion and the number of unpaired electron present in this complex. Okay, try to solve it at your own. Okay, and just send me the answer, and after that I will explain to you. Okay, some people joining very late. Okay, B. Just try to solve at your own, please. A. Okay, so I don't know what will the answer. Okay, I'll solve. Anyone else who is willing to give the answer for this question? Complex is now B is the correct answer. Okay, no issue. This is the last question of today's assignment. And for your information, all the slides and videos links will be shared to you. Okay, what you have to do, you have to just log in on the course portal using your login credentials, and at the left side you will see the interactive session type of tab. You will click on that, and you will getting an excel sheet containing both the files. That is, first one is the ppt file, and the second is the video link for that. Okay, so let me now explain this one. First work you have to do, you have to just check the oxidation state. Okay, so the oxidation state will be, let me do it full screen. X, if I consider the oxidation state of nickel is X, and cyanide, that is Cn negative. Okay, that will be 4 into 1 and equal to minus 2. So x will be minus 2 plus 4. Okay, so it will be plus 2. Okay, so what will be the electronic configuration of nickel? Sorry for the, just wait for 1 or 2 minutes. It will show 3D 8 type of electronic configuration. Okay, so if I fill in the 5 d orbitals, it will be 5, 6, 7, and 8. Okay, so basically if I see, there are two unpaired electrons, but since cyanide is a strong ligand, okay, what it will do, it will just pair up these two electrons, and this will be explained to you in, when you will read the when you will read the crystal field theory of bonding of coordination complexes. Okay, so these two electrons are paired up with each other. Okay, so the oxidation state was plus 2, and the number of unpaired electrons are 0, right? If water, it was water, then what will be the case? It contains two unpaired electrons. Okay, so that those things will be explained to you in the crystal field theory, when you will read about how these strong ligands can pair up the electrons with each other. Because in the CFT, crystal field theory, the d orbitals are basically degenerated, and they are distributed like this: T to Z and EZ. So, what the strong ligand does, the energy difference between these two uh, orbitals are very high. Okay, so all these electrons will be pair up, right? So, those things will be explained in detail later on. Okay, so this was all about the assignment 1. If you are, please explain the last one. Which one you are talking about? You are talking about this one, right? No, it is clear. Okay, okay. Thank you. So it was just all about this session. If you have any query, you can just post into the discussion forum of this particular course. Okay. So at last, I would like to thanks all of you for attending this first session of this course. Okay. So thanks again. Okay. I'm leaving the meeting now. Thank you, everyone.